Now I'm going to show you the concepts for price differentiation or price discrimination. One of the ground rules for discrimination is that you have partner revenues on different markets. In this case, it's only two. Normally, you have a home market, and then you have an export market, which is also the case of in this example. Let's say that we have a home market that is a function. This is a function saying minus 3 or 120x plus 900. So this one starts at a at a price of selling 0.0 units will be 900. So it starts way up, very high price. And of course, because the price is so high, you're not selling anything. But the ground rule is that as long as the marginal revenue on the home market is higher than the marginal revenue on the export market, you should stay and sell on the home market. But you should only stay and sell on the home market as long as the marginal revenue on the home market is higher than or equal to marginal revenue on the export market. And in both cases, you should never sell more than till when marginal revenue is equal to marginal cost. So that's the ground rule. Marginal revenue on the home market has to be higher than or equal to the export market marginal revenue, and that one has to be equal to or higher than the marginal cost. In this case, we have a home market price called PH, which is the one up here, minus 3 or 120x plus 900. And then we have a selling price on the export market, which is 600, and we can sell anything that we want to sell at a price of 600. We also have a little bit of knowledge about the average variable cost. We know the average variable cost is 3 or 120x plus 200. So that's the information that we have about this task, say so. So we have to solve when this is going to happen. The marginal revenue is higher than or equal to the marginal revenue on the export market. So the first thing we have to do is to find the marginal revenue, and you can do it in two ways. Because it's an x squared, it's a parabola when it's x squared. We know that the slope of the price is twice as fast. So it falls twice as fast because it's a minus, it's going down twice as fast. But we can also differentiate the marginal revenue. And we can also differentiate the revenue function. To be able to find the revenue function, we say that the revenue is equal to price times x. So in this case, we have the revenue where we have the price, and this is the price, minus, put brackets about it, it's more easy to understand it then, 3 on 120x plus 900, and then you times everything within the brackets with x. So your revenue is equal to minus 3 or 120x squared plus 900x. And then you can differentiate that. The little trick is when you differentiate, you take the 2 up here and put it down in front and times it with 2 times minus 3. Then you get minus 6. The denominator stays the same, but you deduct the 1 that you put in front, so you have x plus 900. Take that 1x, invisible x, you have 1, which is always invisible when it's 1. Put it down in front and times it with 1 times 900. That gives you 900 x minus 1. That gives you x0, which is equal to 1. So the marginal revenue for the whole market is minus 6 or 120x plus 900. So here you can see, because it's a parabola or x squared function, it falls twice as fast as that one. So what we're going to do now is to look at that one. And what we can see that is that px for the export market is a constant. And when you have a constant, you're selling 1 unit at a price of 6. So you're selling 2 units at a price of 2 times 600. And that's 1200. So the next X1 that you're selling, the marginal revenue must be 600. So when you have a constant, the marginal revenue is equal to the constant. So in this case, the marginal revenue will also be 600. Okay. So we have that one, with, which I made red, which is the home market, call it H. And we have the export market, EX. So we have those two now. So I have to put those two together to see what happens. Okay, so I will erase most of this. So now I have marginal revenue at the home market, which is equal to minus 6 over 200x plus 900. That's the one. That has to be equal to that one, 600. Okay. What do we actually have now? I can show you. I'll erase this. Remember, it's 600. So what we have, if you should sketch it, you have your price and you have your units sold. Up here, you have your price function starting at 900. It goes like this. It's the dotted line. That's the price function. But what we're going to look at is the marginal revenue. And the marginal revenue falls twice as fast. So that is illustrated like this. I don't want to go that far down because I only want to go down to 600. Because at a price of 600, it's more profitable to go to the export market than stay at home, because the marginal revenue will be less than if you go to the export market. So that will go out here as a straight line. And then in this case, this example, you can sell as much as you want on the export market. So you stop at 600, and then you have the two curves: marginal revenue at the home market, marginal revenue on the export market. The only thing we need to optimize how much we're going to sell, the volume as we call it, is we have to find the marginal cost from the average variable cost. Well, it's basically the same concept as the first one. If you have the average variable cost, you can find the variable cost by times it with x. So you have variable cost is equal to average variable cost times x. So the variable cost will be plus 120x plus 200, and then you times it with x, and then you have the variable cost. That would be 3 over 120x squared plus 200x. So to be able to find the marginal revenue, the revenue cost, sorry, I have to differentiate that one, the variable cost. So my marginal cost will be 6 over 120x plus 200. So I'll start at 200 and be able to see where those two intersect, and I'll have the volume. want to see where it is, we have to solve that one first. To find this intersection, we have to say minus 6 over 120x plus 900 has to be equal to 600. And to find the volume, we take the marginal revenue and the 600. So we say 600 has to be equal to 6 over 120x plus 200. We should be able to solve these. So we have 300 times 120 divided by 6. So x is 6,000. So the first 6,000 is going to be sold at home. That's the H, at home. The rest from here and out to the volume is going to be sold at the export market. And to be able to find that one, we have to find the volume. And the volume will be 400 times 120 divided by 6. 8,000. X is equal to 8,000. So we have, instead of the volume, I erase that one and write 8,000. So in this case, we are going to sell 2,000 for the export market and 8,000 as a total. And then we should be able to find the price on the home market by setting the number 6,000 into the price function and find the price. We can do that by setting P is equal to minus 3 over 120 times 6,000. I need my calculator to be able to do that. Plus 900. So we have 3 times 6,000 divided by 120. So I have to deduct 150. So the home price in this case would be 750. And the export price will be 600. And we can find that revenue then. But the peculiar thing about this is that you're selling at a price that is 750 at the home market, and you're selling at the export market at a price of 600. That's a little bit difficult to comprehend because the price is 750 compared to 600, and people can't really grasp that. But that's because of the market revenue. What do you get from the next textile you're selling? So you have not to look at the price function, but you have to look at the margin of what are you earning for the next one that you're going to sell. So that's the concept for solving price differentiation when you have a function and a constant. Thank you.